After having manipulated the state variables, assigning the parameters, using the inheritance, now it is the time to enrich our simulation model with more communication and networks related insight. That is, in this particular module, we are going to start with a fundamental assumption that we had rebuked till now just for the sake of simplicity. Here, we are going to bring it again. That is, when one node sends traffic to another node, there is a propagation delay which is involved that we have already seen. We assigned 100 milliseconds propagation delay to our TikTok example so far. But when a node receives a packet, it needs time to store it, to carry out some operations on it, and send it back. This process involves some finite time that is usually known as the processing time. The processing time so far was ignored, but here we are going to implement it using the simulation model we have been following. In order to implement the processing delay, we must understand that processing takes some time. How to measure that time? For that, we need to understand the concept of timers. So what is timer? Timer is actually a clock that starts ticking on the arrival of an event, and it continues to tick till the arrival of another event. So when a timer starts and when the timer stops, something happens. This is what we call the event. Here, we'll see that in order to implement the processing delay, we need to implement the timer along with event functionality. For that, we are going to look at two files, the TikTok6.ned file and the txc6.cc file. How to implement the concept of timer and event? Let's make a strategy. Here, what we assume is that creation of a message on the sending side takes 5 seconds. So the initialize method is going to make a delay or introduce a delay of 5 seconds. The receiving side receives the message, holds it for 1 second, and then sends a message to itself and sends it back. So we see, if you look at the visualization, we have the tick node and the talk node. The tick node takes 5 seconds for initializing or bootstrapping, or we say for gearing up. Then it takes 1 second to process, to transmit this message to the talk side. On the talk side, when this message is received, a delay of 1 second is introduced before sending it back. Now, we need to add two variables to the class. That is, one is the event. Event tells us when to send, and the TikTok message needs to be buffered or stored temporarily because it would be the same TikTok message that would be sent back. So in order to hold it somewhere, we need to introduce a variable called TikTok message that will tell what to send back. Let's look at the tx6.cc code. Here, we define a new event that extends the message class. The operation of the event is given in lower part of the code snippet. Here we see that the event determines that when the event is true, the scheduling of the first message takes place, and correspondingly, the event is scheduled at 5 seconds. So here you see there's a function called schedule at. It has two arguments. The first argument is the time, and second argument is what is to be scheduled, which is the event. So when this scheduled event is executed, it will result in the initialization of the packet from the tick side. Here, this is what happens? If the event is true, it means that the wait period is over and the message is sent back. If the event is such that this message is not being sent from the tick side, rather it is being received on the talk side, so the behavior of the event is going to be different. Here, it is going to be waiting for 1 second, and you can see the lowest part of this code snippet shows the schedule the event at the simulation time, whatever it may be, plus 1 second, and then trigger the event. And this event is going to send back the message, the tick-tock message, back to the tick node. When we run this simulation program in TK environment, we see that the message, as soon as it arrives on the talk side, it shows the message arrived and starting to wait 1 second. This particular part is not showing the operation and the visualization of the operation on the tick side.